Let's look at our exercise for using a digital multimeter. So it says a meter is a measuring instrument. An ammeter measures current, a voltmeter measures potential difference or voltage between 2 points, and an ohm meter measures resistance. A multimeter combines these functions, and possibly some additional ones as well, into a single instrument. Now it's called a digital multimeter because it has a digital readout. Before we had digital readouts, they had a little hand. So this is what distinguishes a digital multimeter from a regular type of meter, which is a measuring instrument. Before attempting to operate the instrument, become familiar with each control. A thorough understanding of how the instrument operates will avoid undue mistakes and minimize measurement errors, instrument damage, and the possibility of personal injury. So it says function and range switch, number 1. This control is located at the center. So here's our multimeter, okay, and this is the switch. So first of all, when I turn it on, you see the digital readout, and it's not measuring something, so it just says 0, okay. So when you're done with the lab today, what you need to do is, until the next class, you're going to put in the off position because of the batteries inside, okay. So there's the digital readout. Common jack, plug connection for the black test lead. So when we look at it, there's 3 connections down here. Okay, so there's 1, 2, 3, just like in the picture here. So the common jack, so we're going to put the black test lead in there. Number 4, which is the next one up, this is for the red lead. You're only going to use the next one if you're only going to switch the red one if you have 10 amps. Okay, so this is the correct positioning of the 2 leads. Okay, so we have the black, which is negative, and the red, which is positive. Now what I did was, on the multimeter, there's different symbols, so what I did was I put kind of a key here in the box. So AC stands for alternating current. Okay, that's the type of current that we have in the wall. And we know who invented alternating current, right? Then direct current is the type that's in a battery, like this. Okay. And then V stands for voltage, A stands for amp. Lowercase k, that's a prefix we already know, stands for kilo. Mu stands for micro, and M stands for milli, but I just put that because we see all these on the digital multimeter. So for DC voltage, what happens is there's going to be a range. So if you look here on the multimeter, see here where it says DCV, that stands for direct current voltage. ACV stands for alternating current voltage. So if I wanted to measure the voltage, depending upon, so we're going to be using this one, okay? Because we're just going to be measuring batteries, okay? Then, so what happens is, if you notice, there's a huge range here. So let me give you an example. So this is a C battery. Now if you look at the C battery, all common batteries that we use, whether it's like a AA, a AAA, a C, or a D, if you look at all of them on the side, because they have this information actually on the battery, trying to see it on here. If you look at it here, this says 1.5 volts. This says 1.5 volts. This one's kind of minute. It's on there somewhere. This is 1.5. They're all the same voltage. Okay? So anyway, if I want to measure the voltage across this battery, I know it's going to be 1.5 volts. Now, some of them I don't know what the voltage is. And when we're doing the lab, we might not know what the voltage of something is. So here, normally you would start off on the normal setting. So you see here it says 20. So 1.5 is a number that it's just like a regular number, like kind of like 20. So when I put the leads on, you see the reading. Oop, you can't see that. The reading here says 1.55. So it's actually not exactly 1.5. See, it's a little bit more. Okay? You see the negative sign? The negative sign means I have this black and red opposite. If I switch them, see how now it's now positive 1.55? Or 1. Does everyone see that? So the negative sign went away. Okay? So it just has to do with the polarity. Okay? So you don't have to get hung up if the answer comes out to be negative, or you can just switch the leads. Now, let's say I didn't know what the voltage was. See where it says 200 M? That stands for milli. Well, milli means whatever I'm looking at, it's 10 to the negative third power, because milli means 10 to the negative 3. So if I put it now on here, you see how it says 1 like that in a space? That means I'm out of range. That means the setting I have is not good for what I'm measuring. If I got a reading, whatever that value was, it would be times 10 to the negative third power. So if I switch it up now and put it on, you see how I get 1,560? Does everyone see that? So then if I took that and I said 1,560 times 10 to the third power, wouldn't that be 1.56 volts? So whenever you see a little prefix, that you just add in the prefix to the reading that you see. Okay? If I put it up here, I guarantee I'm going to be out of range. Or actually, it says 2, because actually it's still in the numerical range. I'm sorry, because there's no prefix here. So anything here, here, or here, but see how this is rounding it to 2 because it's to read larger numbers. That's why it says 1,000. Okay? So that's to measure the voltage. Okay, then resistance. If I look at my digital multimeter, you see down here the ohm symbol, because ohms measures resistance. So it's the same thing. If I want to just read something that's going to be a number like 1.5 or 20, if I put it down here in the 200 range, then the prefix here is K. K means what? Kilo. So if I have it on this range, I would multiply it times 10 to the third power, because kilo means 10 to the third, positive 3. Now next week we're going to do a lab with resistor color coding, and we're going to use these resistors. What we're going to do today on the lab is we're just going to measure a couple of these. So if I want to measure the resistance, I am going to put this on a setting. Right now it's out of range. See how it says 1? And I put it on the resistor like this. I'm still out of range. So I just need to keep adjusting it till I get a value. I'm still out of range. So see how this says 428? But do you see how there's a little K there? So the value of this resistor is 428 times 10 to the third power. So it's 428,000 ohms. Okay? And then I would put that in correct scientific notation. So again, when you have a 1 like that, that means you're out of range. Now let's look at the back. So on our chart, what we're going to do is we're going to do a AA, a AAA, a C battery, a D battery, and a 9-volt battery. And then we're going to do the first 5 resistors. So we're going to do resistor 1, 2, 3, 4, and 5, and then we're going to answer these questions. So that we're just learning how to use a digital multimeter, because we're going to be using this instrument for our labs, all with this chapter and all with the next chapter. So we need to be familiar how to use this correctly.